Okay, let's take a look at sample problem 3.6. Determine the number of moles of carbon in 10.00 grams of naturally occurring carbon, and B, the mass of 0.905 moles of sodium chloride. So for these conversions, where we're going between grams and moles, grams to moles, or vice versa. This conversion is done with what's called the molar mass. The molar masses come from the periodic table, so these are numbers you don't have to memorize. So I'm going to put up the molar masses for this one. The first element we're talking about is carbon, which is element number 6. So look in your periodic table for element number 6, and you'll find that its atomic mass or molar mass is 12.01 grams per mole. For part B, we're going to need sodium and chloride, sodium and chlorine. So sodium is element number 11, and its molar mass is 22.99 grams per mole. And then there's chlorine. Chlorine is element number 17, and it has a molar mass of 35.45. Okay, so those are the three elements we're going to work with. So let's start with part A. We have 10 grams of naturally occurring carbon. So we're going to take the given piece of information, which is the 10.00 grams of carbon, and we want to find the number of moles. So we're going to do a conversion to moles. So here's how you go about it. What we would say is that 1 mole of carbon is equal to 12.01 grams of carbon. That's this number right here. Okay? So the definition of that number is that number in grams is equal to 1 mole of that specific element. So for carbon, the element is carbon. 1 mole weighs 12.01 grams. That's what that number is telling us. So now we use this as a conversion factor, kind of like what we did with Avogadro's number. We want to convert this to moles. So we're going to put the moles in the numerator and the grams in the denominator. And look what happens to the units. Grams of carbon cancel, and you're left with moles of carbon. So 10 grams divided by 12.01 is now let's count the sig figs. Looks like we have 4 sig figs in each value. So 0.8326. So 0.8326, and then the units would be moles of carbon. Okay? So this is unlike the conversion we did in sample problem 5. In sample problem 3.5, we were converting between the number of moles and the number of atoms. Here we're converting between the number of moles and the number of grams, the mass, how much they weigh. So we're not counting atoms, we're weighing them. Now let's try part B. Part B is, of course, going to be the opposite. So we just did a conversion going from grams to moles, so now we'll do a conversion going from moles to grams. What's different about this one is that the substance we're talking about, sodium chloride, that's a compound, it's not an element. NaCl is the chemical formula. So we go back and we say, okay, well, how much is that going to weigh? What's the molar mass of sodium chloride? Well, it has 1 sodium, and it has 1 chlorine. So that would be what? 58.44? And again, the units are the same, grams per mole. So in other words, for sodium chloride, 1 mole sodium chloride equals 58. 58.44 grams. Okay, 1 mole is that many grams. Same thing, conversion factor. So now in part B, we're told we have 0.95 moles. Now we're going to convert that into grams. Okay, here's our conversion factor. Which one's going to go on the top? Which one's going to go on the bottom? The top the numerator is going to have grams because we're trying to find grams. We're trying to get rid of the moles. So if we want to get rid of the moles, we have to divide by moles. So we put 1 mole sodium chloride down here in the denominator. And we put the 58.44 grams of sodium chloride in the numerator. So now the moles of sodium chloride cancel. So 0.905 divided by 58.44. And the number of sig figs for this one is 3 because the 905 only has 3 sig figs. So 0.0155. This is not significant. Leading zeros are never significant. So 155 is 3 sig figs. And then, oops, sorry, my mistake. Look, there's an error. You can see there's an error. How do I know that's an error? I got a small number, right? How is it that taking something that's close to 1, a little bit less than 1, and multiplying it by something that's in the 50s give you a number less than 1? That can't happen. 1 times 50 would be 50. So we know this answer has to be greater than that. So 0.905 times 58.44, and we get 52.888. To 3 sig figs, that would be 52.9 grams of sodium chloride. So you can always catch your errors just by looking at the reasonableness of what you just did. So part A, we did the conversion from grams to moles. Part B, we did the conversion from moles to grams with the added fact that we had to use the molar mass of a compound, right? This is a compound here. So we had to add those molar masses together for each element to get the molar mass of the compound, and then that's what we used in our conversion.